Hi, we're continuing the topic of temperature markets on Polymarket, and today we'll look at another case. The key idea remains the same. The weather app on your phone is an average forecast for a broad audience, not a precise tool for an exact threshold. The market isn't asking whether it will be cold or not. It asks specifically, will the temperature cross a certain threshold or mark at a specific moment in time, at a certain hour, so to speak. And this changes our entire approach to analysis. The mechanics remain the same. The market settles based on a specific threshold at a specific weather station. Usually this is an official station, most often an airport. Here, you should understand the source as the contract. The resolution rules determine what exactly is considered the result, not what you see outside your window. The logic for the entry time is the same. A week ahead the forecast is too rough, almost 50%. But at a horizon of 3, 4 or 5 days, yes, weather models provide accuracy within 1 or 2 degrees, so that's the optimal entry window. We have a pretty good coefficient for that level of accuracy. Our accuracy is 80%. 81, yes. When two models coincide. For example, it is precisely here, 3 to 5 days out, that a divergence appears between how the market reacts to headlines, like anomalous cold is coming, and what the actual calculations show for a specific day and hour. The tools remain the same. This is not just a random set of websites, but truly the minimum necessary for accurate analysis. The first is windy.com. The temperature layers and the hourly scale don't just show a single number, but the dynamics, how cold, hot or warm air, at what speed it enters the region and when it reaches the desired point. There are layers, wind layers, rain layers, temperature layers, cloud layers, wave layers, and so on. There are many layers. In this case we need the temperature and wind layers. At what speed? Yes, the wind is moving. So we can look here, click here. We need to reach this point. So this temperature, which will one way or another reach there, or here. How long will it take to get there? The average temperature is 26, but here it's already about 25 to 26 on average, so it will hardly change if it changes at all. We can also check here and here. At what speed and in which direction things are moving, how they are moving, and how long it will take to reach the point we need, right? We have too many stations here, too many measurement points here. I think you'll figure out where to find the distance after all. In general, windy is an indispensable tool. It's exactly where we get all our signals from. So if we have two models, right? When comparing two models, let me remind you, the European and the American, we compare the temperature, we compare all the data in general. If the models match, if there is a match in some of the model solutions or analyses, then that gives us a signal to further analyze this event using other tools, to keep watching, to keep studying how and what is moving. Our second tool is wxsr.gov. For America, for the States, it is very suitable and very helpful. It's a very good and accurate tool. And here, the value lies in the hourly forecast for a specific station, yes. So we can see which station we are measuring, where exactly we are measuring, where we are looking, and so on. With this detailed hourly forecast, yes, you can simply move your mouse cursor over it and see exactly what the current temperature is, or even convert everything from Fahrenheit to Celsius. This particular website is extremely helpful for your daily planning. Here the forecast is specifically tailored for a particular station, exactly where, according to the rules, the market result will be recorded, not just an average summary for the region. This is also very important. It really helps and makes the work easier. Our third tool is AccuWeather. It's also a fairly accurate tool, simply as a weather forecast. And then there's wxsr.api, a historical summary, historical data for each city or say the specific location we need. It also provides a lot and is very helpful. If we take a close look and see, when carefully comparing these different meteorological models, a small difference of only 1 or 2 degrees, that essentially means the models are in basic agreement with each other. Well, if they happen to show exactly the same temperature like we are seeing right now, then it is quite obvious that the models are in complete and total agreement regarding the forecast. If the difference is 3 or 4 degrees, that's a signal that the atmospheric situation is unstable and confidence should be proportionally lower, regardless of what the market price says. Let's analyze some event, any event. I opened São Paulo and was already getting ready. São Paulo, June 23rd. Will the temperature be 20 degrees? We bet on yes. As I already showed, we recorded a maximum of 71.6, but it was recorded not at the point where we were measuring. That is, at first we also went to Windy. Of course I can't show you now because Windy doesn't store historical data, but we also went to Windy, checked the points, the winds, and where everything was moving. We also analyzed it, and that gave us the signal to move forward. We went to the Wizard API, checked the forecast, and as we can see, 70 Fahrenheit is about 21 degrees Celsius. Well, Wizard Gov is for America, São Paulo is in Brazil. June. The 23rd, 21 degrees, and just like that. Well, I explained it quickly now, but back then this analysis also didn't take much time. It took about 10 to 20 minutes, I think. So basically it was a simple analysis, but the event worked out, it played out, and we made $700 from it in just 10 or 20 minutes. There are also some pitfalls. These are the same fundamental points as always. Check which specific time of day the threshold is tied to. The nighttime minimum and the daytime maximum are different resolution conditions. Check the station. The airport is often colder or warmer than the city center, depending on the terrain and the buildings. And keep an eye on liquidity during extreme events. Market volume can surge sharply in the final hours, and this is also something to consider when entering. And to summarize systematically, the gap between the market price and the actual probability in temperature markets almost always arises for the same reason. The market reacts to how the threshold sounds, not to what atmospheric physics actually shows at a given moment. Extreme thresholds, whether it's heat above record levels or cold below the usual, are systematically underestimated or overestimated by the crowd, because human intuition works poorly with the tails of distributions, while meteorological models, on the contrary, are most informative precisely in such situations. Atmospheric fronts either have a clear, predictable trajectory or are obviously breaking down. There are few intermediate states, therefore the working methodology is simple. Don't try to predict the weather intuitively, don't just check the app on your phone, but instead measure the degree of agreement between independent models and convert this agreement into a probability estimate, which you then compare to the market price. The difference between these two numbers is the only thing that matters when making a betting decision. Subscribe to see more case studies like this. Goodbye, everyone.